Hello. Today we are going to talk about image classification using neural nets. So what's this video for? I originally thought about making this video for my friend because we're going to work on an interesting project, and I thought it would be a good thing for him to see the power of neural nets. But anybody really can watch this video. Even a high schooler should be able to follow along and use this in their projects or a professional. So what is image classification all about? Image classification is just take an input image and then classify that image into a category. For example, when you're on social media, you're trying, companies usually try to filter content. You can have sensitive content that's too graphic and you want to classify it as bad and normal images as good. Or even in a more professional setting during manufacturing, you can have a machine that just takes pictures of things on a conveyor belt on the line and then determine what object it is and then do something about it. But how do you actually do that? The first thing is, in normal circumstances, if you're trying to write a program to do anything, you have a set of rules that you input into the program so that it behaves the way you want it to behave. Now, in the case of images, it's a bit more difficult because even for a simple problem like differentiating between a dog and a cat, what are the rules you're going to use to differentiate between the two objects? A dog has a tail, so does a cat. A dog has a fur, so does a cat. A dog has two eyes, so it's very difficult to find a set of rules that you're going to input into a computer to make the difference. In fact, how does a computer even know what an eye is? So that's why whenever you have a problem where the rules are not clear, but you know you can do it, but you don't know how to describe how your brain does it. Whenever you have a system with unclear rules, that's where neural nets usually come into play because all neural nets need to work is just a bunch of examples, the input examples and the corresponding output. If you have enough of them, then your neural net should be able to approximate the behavior you want from it. And what is a neural net exactly? A neural net is just something like this. And all these lines are weights. So neural net is a combination of neurons where each neuron is just a set of weights. So these are weights and these are neurons. The way you combine the neurons together is called architecture. And mathematically speaking, if you have a really big neural net, it should be able to approximate anything as long as you have enough data for it and time, of course, to wait for it to train. Now that you have a brief overview of what a neural net is, let's go a bit more into how then to train a neural net to classify images. So we don't need to start from scratch to do that. People have already trained models, other neural nets for their specific problems, for probably problems that are bigger than yours. So what we are going to do is just take one of those models and then repurpose it to use it for our own use case. Now, the first step for that is you need to have VS Code to follow along. So if you do not have VS Code, I'll just add the download link to the description, but you can just look it up on Google and download VS Code. And then when you're done downloading VS Code, you should go to the extensions. This is how VS Code looks like. You just go to extensions right here and download Python, the Python extensions, these three Python extensions if you don't have them already. What else? You need to download Jupyter because I use Jupyter in this tutorial. So you need to download this this Jupyter extension. And if you don't have Python installed on your computer, you also need to install Python. Now for the file we are going to use for this tutorial, there's a link for it in the description. So you should just be able to follow the link. Let's see, follow the link and download the file. The file, I think I have it on my desktop already. Yeah. So this file, let me put on desktop. So download this file and then extract everything, extract all. So in that file, we have the images, because today we are going to train a classifier. Just for this tutorial, we're going to train a classifier that takes in images of animals, takes an animal and then determine what animal it is. We have 10 types of animals in our training data set. And this is how the, the data set looks like. We have the butterfly. We have tons of images of butterflies. We have tons of images of cats. And how your data set has to be structured is just this. So you have each folder corresponding to each class. Maybe in your use case, it's parts of a car. In this case, it's just different animals. And for each folder, you have images containing the objects of interest. So that's how the data set is supposed to look like. And then when you're done extracting the file, you can open VS Code. And when you open VS Code, you should see this is the data set with the raw images that I talked about already. And now we have two important files. If this file is what we are going to use to train the model, and then this file is what we are going to use to deploy the model, like after we're done training. Because really the goal is to get, in this case, we already have an architecture, a neural net, and we are just trying to modify the weights of the neural net to fit our purpose. So that's the final goal, is to have a file that is just our neural net with the right weights for our problem. Now, to get started, the first thing you want to do is create a virtual environment because you don't want to mess up the libraries you have already installed on your computer. So I recommend that for every project, you first create a virtual environment where you install all the libraries necessary just for that project. Now, in this case, I know some people have CPUs and others, some people have GPUs and others do not. So I created, you should be able to follow along no matter whatever you're using. You can use a GPU or just a CPU. So let's create a virtual environment. Okay, so you can see the virtual environment has been created. Now we have to install the necessary libraries. If you do not have a GPU, Okay, so this is the command pip install. This is I use this because I have a GPU. So requirements.txt. This file you run the if you have a GPU. Now, if you do not, okay, actually, I already so I created a virtual environment. I have to activate the virtual environment first. So to activate the virtual environment, you run scripts activate. So this is the name of the virtual environment we just created. Scripts activate, and now we activated the virtual environment. Now the next step is installing the libraries. So I already have the list of libraries in different files. This is for someone that has a GPU, and this is for someone that doesn't have a GPU. So I just do pip install our requirements.txt. If you do not have a GPU, of course, you're going to do pip install CPU only requirements.txt. So so this is almost done. Okay, now it's done. It's time to train the neural net. So the first step is we need to select the kernel that's going to run Jupyter. We already created a virtual environment, and this is how you probably see different options. I have different Python versions that have been installed. So, but then what you want to use is the virtual environment you just created. So this is even recommended. So you click on that, and now we import the necessary libraries, and then here is just setting a seed so that everybody can get the same result. Um, so here, everything I put in this type of context means these are things you can modify. So the data set in our case is stored in this folder, animal 10 raw images. That's why I put data directory. And in that directory, we know those images have different sizes, but the neural net is expecting everything to have the same size. So we need to all transform and normalize all the images in the neural net in the data set. That's why I define a transformation. And then after defining a transformation, I create a data set. Now, Torch, which has been developed by Facebook, has nice utilities that you can just use to create your data set. So you just specify the directory of where the data set is found and the transformation, and then it just creates a data set for you. Now we split the data set into a train, validation, and test. So the train and validation is just what we're going to use for training. I'll get more into that later. And at the end of the training, we have a test set to be able to report the performance of our neural net. So that's what I do right here. I just split the data set into train, validation, and test. Now, remember that this data is just stored on your hard disk. But then if you have a GPU, you might want the data, you know, if you want to have the GPU, the training, the processing of the data is actually going to be done on the GPU. And if you have a CPU, it's going to be done on the CPU. So you need something to take care of loading the data, the batches of data from your hard disk onto your GPU or your CPU. That's why we have this data loader. And we specify the batch size, which is 256 in this case. And shuffling is so that each time it takes the data, shuffles the order in which it batches the data. Now, so let me run that cell. Now, this cell is just so that we can visualize stuff in line. Okay, so the first thing you always want to do before you proceed with the training is check the data set because neural nets are not like regular programs. They fail silently. Unless you explicitly go and check what's happening, you might not even know that you're training on the wrong data set. So that's why we always need to check the data. I wrote this utility function to just load one batch of data and then display the labels. I don't know. Let me zoom in maybe. Okay. Let's see. So you can see these images is one batch of data. You have squirrel, cat, dog, elephant, chicken. Yeah, the data looks all right. And they all have the same size. Don't look like they have been modified too much. Okay, so we are good to go. So after checking the data, let's just check the class names. So these are the class names that are present in the data. And I defined the class names variable. I had defined it above. This is where I defined it, class names. All right. Now that we are done defining, checking the data and setting up the data loader that's going to be used for the training, we need to define a neural net architecture, how the neurons are combined together, how many neurons we even have. Now, for this case, we don't need to think about that because people have found architectures that work for them for even bigger problems. And all we need to do is just use that architecture, modify the weights a little bit to fit our purpose. So what I'm doing right here is I'm loading a pre-trained model that's ResNet, and I am modifying the final layer because ResNet I think was used for ImageNet with 1,000 classes. In our case, we only have what, like 10 classes. So we modify the last layer, the ResNet architecture. That's what I'm doing right here. So I loaded a pre-trained model, that is the weights of the ResNet after training, because they're already probably really close to what we want, and all we're going to do is just modify them a bit. So after loading the pre-trained model, this is defining the loss function. And here is the optimizer. So the optimizer, it's what's going to do the updates of the weight at every iteration. In this case, I use Adam with a learning rate of e to the negative 4. You can, and this is the parameters that the Adam is going to optimize. You can play around this learning rate, but I recommend to keep it between -4 and -3. Now the next step is I check I need to make sure I have the device because some people have GPUs and others do not. So I check the device. Let me run the cell. So I have a GPU. That's why the device right now is CUDA. If you have a CPU and not a GPU, it's just gonna show CPU. And now this is the training function. So what does the training function do? It needs to take the model you want to train, the criterion that is the loss function, the optimizer, in this case is Adam, the train loader, and the validation loader, plus the number of epochs. So for each epoch, we set the model to training mode, and then we load the training data from the train loader that we defined above. So what this does is it takes the data from the hard disk. And when we take the data from the hard disk, we need to move the data from the hard disk onto the device we are using. In my case, it's a GPU. For you, it might be a CPU. I take from the hard disk and move it to the GPU. And then here is the gradient. I zero out all the gradients of o- of um of the neural net. If you don't know what gradient means, just look it up. I zero out the gradients and then I run a forward pass. So after running a forward pass, I compute the loss and then it's a backward pass, the back propagation. And then I have the optimizer that updates the weights of the neural net. Now, this is just keeping track of the loss for user experience because I keep track of the loss and display it. So that's a training iteration. Now, for evaluation, I have um, I just use I just use the validation data just to check the performance of the model so far. Now that we have defined the training loop, we can train the model. So I run the train function. Oh, I have to run this first. Okay, so I put 5 epochs because that's more than enough for this data set. And it takes about 5 or 10 minutes on computer that has a GPU. I have a 3090 from NVIDIA, and it takes 7 minutes to run the training. If you're only using a CPU, it's probably going to take 1 hour. Now, when the training is done, this function is just there to plot the performance. So we can see that after 5 epochs, you can see the training loss goes down, and then the validation accuracy keeps going up, but then declines at the last epoch, epoch number 5. Now, this is just a particular case for the animal data set. Let's say you have another data set. You might want to modify the number of epochs that you train for, the learning rate, as I already mentioned, and you want to make sure that you stop training. Like when you look at your curve, you need to make sure that the the training, well, the training loss is probably almost always going to go down, but this is the validation is why it's important because you usually want to stop when the validation accuracy doesn't improve. Now, when you're done with the training, you want to visualize how good the model is actually performing. So I remember I mentioned that you split the data into the training, validation, and the test set. Now, during the training process, you have the validation data that tells you how the model is performing. And you might go back and tweak the model, like changing the learning rate and the number of epochs it trains for, or even the loss function, like other parameters to make sure that your validation accuracy is good. In this case, it's about 96%, which is good. Now, if you use the different parameters, it might perform worse. Maybe it's 80%, and you go and tweak those parameters and change the optimizer to get better performance. But now, because you're tweaking the model based on your validation is also part of the training. You- It's not you're not directly training on the validation. You're training on the training data, but because you're tweaking your model based on the validation, it's also considered part of the training. So you don't really know how well your model is performing unless you have a completely separate data that you will use at the end to test how good your model is performing. So that's why we have the test set. So when you're done with the training, um, so this just puts the model into evaluation mode. That is, it doesn't keep track of the gradients because usually the model is expecting to do a forward pass and keep track of the gradients to update the weights. But in this case, you just put in evaluation mode so that it's quicker. And we touch the no grad so that it doesn't keep track of any gradients. So here is just we're just running the model on the test data. That is data that the model has never seen and that we have not tweaked the model on. So we have, seems like it's performing well. So the true predictions and this is the prediction of the model and these are the ground truth value. Let's see if there's any mistake. All right here. The model said this was a spider, but it's actually a butterfly. Well, fair enough. What else? Um, doesn't seem like there's any other mistakes. Okay, here, the model said that this was a cow and it's actually a horse, which is probably because of the color pattern on the horse that looks more like a cow. Well, fair enough. Here, the prediction said elephant, but the true, it is actually a cow. This is not re like this makes sense. The model was tripping on examples that are kind of difficult because I myself wouldn't, okay, yeah, it's if I see this, I know it's a cow. Yeah, but it's performing well. I actually asked a friend of mine to send me um an image so that we can see how it's performing. I'll do that right now. So after the training is done, what you want to do is after you're done all the training and it satisfies and you think the model is satisfactory enough, what you do, you save it because that was the final goal, to have that file that has the weights of the model. So we save the weights and the name I used to save it was animal classifier.pth. So the model has been saved and now it's ready to be used in any program. Now let's see. So to use it, it's pretty simple. It's just a Python function. Now the only thing that may be a bit challenging for some people is this. When you save the weights, if you want to load the weights, these are just numbers, these are weights. You need to define the architecture the same way the weights, because the weights have been saved from a model that has a specific architecture. So you need to define that architecture as well, and then load the weights onto the architecture before you're able to use the model. So somebody can do this training, let's say OpenAI or some other company. They finish the training and they give you the weights, and all you have to do is just define the architecture, load the weight onto the architecture, and then use it. So that's what I'm doing right here. I'm just importing the libraries again. I'm selecting my virtual environment. And then this is the load. This is a function I use to load the weights. I just check if CUDA is available. That is, if you have a GPU, I put the weights onto the model. And I answer the class names we had before in the training phase. And here I'm defining the architecture again because I need to define the architecture. I define the architecture. And when I'm done defining the architecture, I load the weights that we already trained onto that architecture. And when I'm done, I move my model onto the device I'm using because I might be using a CPU or a GPU. So I move the model, the neural net onto that device. And this function is a functional root that takes a model, the image, the path of the image, and the class names, and then tells you image, what class the image belongs to. So my friend sent me a dog. Let's see if I can see it right here. So this is a photo he took of his dog, and let's see what our model thinks it is. So I run this, and it says it's a dog. And this is what I just downloaded from the internet, a mammoth, which is not an elephant, but let's see what I guess the model is probably going to think it's an elephant because it just needs to predict to give a value to one of the 10 different classes. And this looks more like an elephant in the data set. So if we run the prediction, it predicts that it's an elephant. So that's it. We set up the environment to train the model. We train the model, and now we are able to use it. You can use it anywhere. You can put in a Python script. It can be running on a server, on a Django server or any other server. You can have it set up in your manufacturing plant where something is just sending images onto a network, and you have your Python script that just classify the images and does stuff with it. So that was it for this video.